So example 3, again, we start by factoring. Step 1, factoring this. And this is a tough one to factor. In order to get a negative 2x squared, it would have to be negative 2x and x. In order to get 2, you would need 2 and 1. I'm going to put the 2 here and the 1 here. That way my outside is 4, my inside is 1, because I want to get a 5. If I want to get a positive 5, I need positive 4 plus 1, positive 5. So we factor the top. Step 2, I always wrote these in green. There we go. Step 2 are non-permissible values. X can't equal 1. What is that going to be? Does it cancel out? No. So we end up with a vertical asymptote at x equals 1. Nothing canceled out, so we are still using our original equation. Every one that we've done so far with a higher degree on the top is always canceled out, and we've ended up with a line that we could just draw. This time, it didn't cancel out. We still have a higher degree in our numerator than our denominator. This is the situation in step 3 where we have an oblique asymptote. Now, we looked at this earlier, but might not remember exactly. When you have an oblique asymptote, you're going to use synthetic division to find it. So what was our original equation? Negative 2, 5, negative 2. Negative 2, 5, negative 2. We are dividing by x minus 1, so you would put a positive 1 outside. Bring this down, multiply, add, multiply, add. You can ignore the remainder of 1. What is the answer that you are left with? You are left with y equals negative 2x plus 3 as your oblique asymptote. And just like before, I'm going to start graphing this. So we know we have a vertical asymptote at x equals 1. I'm going to graph negative 2x plus 3. It would have a y-intercept of 3 and a slope of negative 2, meaning going down 2 over 1. And label that asymptote as well. Step 4 are our nice points. We're going to find our x-intercepts and y-intercepts. The y-intercept is the easiest. Go back to your original equation. Plug in 0 for x. Can you see that you would get negative 2 over 2? Our y-intercept will be positive 2. I'll label that on my graph. 0, 2. For my x-intercept, or x-intercepts, we've already factored it. By factoring it, you are able to find wherever your numerator is equal to 0, you'll have x-intercepts. So we're going to have one at 2 and another one at a half. Label those points. As well. And now we check, do we have enough points to graph? Well, x equals 1 separates your domain into two sections. Your oblique asymptote, just like your horizontal asymptotes, doesn't separate your graph into two separate domains. So the fact that I have 0, 2, and 1/2, 0, these are going to connect, and then we're going to go towards our asymptotes. The fact that I have the point 2, 0 means that my graph is going to go towards my asymptotes there as well. In fact, I do not need to add any more points. So as soon as you have a point and you can make it go towards the asymptotes, you have enough in that section to be able to graph it. Just going to reread the question, make sure it didn't ask about domain or anything. It did say state the domain and range. So the domain for this one, x can't equal 1, but x can be anything else. And your range, it goes up forever and down forever, no holes in your graph. Your range is everything. So we haven't seen an oblique asymptote for a while. Try question 5 to practice some like this.